Hey everybody, it's Miss Marian and I'm back to talk about another fraction concept with you, and that is adding and subtracting fractions, but this time with mixed numbers. This is also includes some regrouping with both addition and subtraction when we work with fractions greater than 1. Alright, so coming over here we have some examples of a mixed number. This is 2 1/4 plus 1 2/4. We're going to start extending this to understanding that the fractions do not have to be written horizontally. They can also write them vertically. This helps with mixed numbers a little bit because now we can see that we're going to be adding whole numbers together and fractions together. Sort of keeps it separate. When we were just working with fractions that didn't have a mixed number, writing them like this is easy because you can see the numerators line up and we're working with the denominators. This way will help us to see we've got a whole number and fractions over here. Alright, so what does this look like in the model? This is 2 wholes and 1/4, and we're going to add to that 1 whole and 2/4. So I'm going to add a whole another whole, and then I'm going to add 2 more fourths here. Okay, so we're going to be able to see very quickly, we can put the wholes together. So I'm going to add my 2 wholes and my 1 whole, which is going to give me 3 wholes, which is what I have here. My denominator is fourths, that always stays the same, and my numerator becomes 3 of them. And you can see on my model I've got 3 3/4, just like my model here. Again, vertically we can add 1/4 plus 2/4, sort of ignoring my whole number. This is from last week. 1/4 plus 2/4 is 3/4, and 2 plus 1 is 3. Okay, so 3 3/4. Pretty simple until we get to one like this. This is 3 3/5 plus 2 4/5. If we were to just straight add this on paper, as I did up here, the paper pencil strategy, adding my mixed numbers or my whole numbers first as part of my mixed numbers, the 3 wholes plus the 2 wholes is equal to 5 wholes. Again, we could rewrite this as 3 3/5 plus 2 4/5 if we wanted to write that going up and down. I can see my whole numbers there. 3 plus 2 is 5. Okay, adding my fractions. Denominator stays. We're just counting fifth size pieces. We've got 3 plus 4, which is 7. Okay, and same thing here. 3 plus 4, 7/5. All right, now this is a problem. And last week we said we could leave fractions greater than 1 or make them into mixed numbers if we like. But this is sort of a combination of both. This is a mixed number, but it's also a fraction greater than 1, and we want to get rid of that. So we want to rewrite that correctly. So let's go to our model first, and we're going to see what that looks like. So the first one is 3 wholes. Notice every hole is broken into 5. And 3 parts out of my 5. And I'm going to add to that 2 wholes and 4/5. And I'm going to, instead of having it completely separate, I'm going to start filling in that fraction together. So 3/5 plus 4/5 isn't going to fit. It's going to have to overflow into this one. Okay, so what does that look like? Yes, there are 1, 2, 3, 4, 5 holes, but because this one has gone over the 5/5, because this has gone over 5/5, we've made an extra hole. So we're going to look at 7/5 as being a fraction greater than 1, which we did last week. So if 5/5 is a whole, this is 1 whole and an extra 2/5. My answer is not going to be 1 whole and 2/5. It's going to be 1 whole and 2/5 plus the other holes that we have here. So we're going to rewrite this into an extra whole, 6 holes, and 2/5 left over. 1, 2, 3, 4, 5, 6, and 2/5 left over. Now, in order to be able to do this, you have to have a good understanding of how to turn fractions into mixed numbers, fractions greater than 1 into mixed numbers. Something like this, where you have fourths pieces and you need to shade in 10 of them. So we're going to work with 2 strategies for turning fractions into mixed numbers. One of them is a model, and the other one is using division. So as a model, we're going back to the very beginning of fractions, day 1 of fractions. What does this fraction mean? The most important part of the fraction is the denominator. It tells me my whole is split into 4 parts. If I wanted to shade in 10 of them, that's not going to be enough. Okay, 2 of them will give me 8/4. In order to get 10/4 shaded in, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what do I have modeled here? 2 holes and 2/4. Okay, you can always draw a picture for these anytime. Now, if you say, I don't want to draw a model for everyone, you can use division. This is 10/4, which is basically saying I'm going to take 4th pieces or groups of 4. How many holes am I going to be able to make out of 4/4? So you're basically turning this into 10 divided by 4. We worked with division and flipping that around and thinking multiplication. 4 times 2 is going to be 8, and that leaves me with 2 left over. What are those leftover pieces? They're 4ths. Okay, so it just becomes a division problem. If 10 divided by 4 is going to be 2 with a remainder of 2, my way of showing that as a fraction is 2 holes with a remainder of 2, and what those 2 pieces are is their 4ths. The more time students draw this picture, they're going to start to say, wait a minute, why am I drawing this every time? I know that all I'm really doing is doing division. So some students are able to get there a little bit quicker than others. They don't need the model every time. But either one of those strategies, both are very easy to do. And students should be able to turn fractions greater than 1 into mixed numbers at minimum by doing this. Some students might be ready for a shortcut, and this is that. All right, that was addition. Now let's get into some subtraction. All right, this is 3 6/8 minus 1 3/8. 1, 2, 3 6/8 minus 1 3/8, which means we're taking away 1 whole and we're going to take away 3/8. 1, 2, 3. So what are we left with? 2 holes and 3/8 left over. Okay, if I look at my subtraction problem, looking at my whole numbers first, 3 minus 1 gives me 2, and 6 minus 3 gives me 3. These are 8th pieces. Again, if you like it vertically, 6 minus 3 is 3. They're 8th pieces, and 3 minus 1 is 2. So with a model, horizontally or vertically. Seems easy enough until you get to one like this. This is 3 2/5 minus 1 4/5. One hole, 2 holes, 3 holes, and 2/5. Okay, now if I just go straight to paper pencil, which students are going to be ready to do, they're going to say, forget the model, I don't need that. The problem is, you can't do 2 minus 4. 2 minus 4 doesn't work. Most students will look at that and just flip it around and do 4 minus 2, but we've been learning since 1st grade with subtraction you can never do that. When you can't subtract, what do? Same thing since 1st grade. If you can't subtract, you have to regroup. So we're going to learn how to regroup with fractions. Now most students think, well, I know how to regroup, all I do is take 1 and give 10. And that doesn't work with fractions because we're not in a base 10 system. We're based on wholes, and wholes can be a lot of different things. They can be 3/3 or 4/4 or 5/5 or 8/8 or 10/10. So in this case, we're dealing with a little bit of a different problem. So if I just looked at my model here, again, you can always draw a model. So models can always help even if you can't understand the regrouping. I have my 3 2/5 and I want to take away 1 4/5. I'm taking away 1 entire whole, and I need to take away 4/5. Well, right here I only have 2/5, which means what's going to happen is I'm going to have to dip into another one of these holes. Okay, what does that leave me with? That whole thing's gone, all of that's gone, and those are gone. So it leaves me with 1 whole and 3/5 left over. All right, now how does the regrouping look? Well, when I can't do 2 minus 4, what do? We're going to take 1 and make that 1 less. Nobody has any problem with that. Everyone understands that. But what do we make this? Students are going to want to turn this into a 12 because they've always been taught we're going to take 1 and we're going to give 10. But really what we're doing is we're taking away a whole. So I'm taking a whole and I'm giving a whole over here. Well, what is a whole? I'm working with fifths, so my whole is going to be 5/5. So I'm taking 5/5. I don't have to write this. I can sort of keep this in my mind, hold this in my mind. So I'm taking 5/5 plus the 2/5 that's already here. So really, as I'm regrouping, this 2 is going to become a 7/5. When I look here, what this really is this is when I took away, when I wanted to look at this a different way, this then becomes 2 and 7/5. So 2 and 1, 2, 3, 4, 5, 6, 7/5. So this is 2 and 7/5, or it's 3 and 2/5. So there's two ways of looking at that. Now we're going to subtract. 7 minus 4 is 3/5. And 2 minus 1 is 1. So 1 and 3/5 using a regrouping strategy or using a model with paper and pencil. In order to be able to do this, we're going to have to be able to rename mixed numbers into fractions greater than 1. The opposite of what we did here when we renamed fractions into mixed numbers. And again, two strategies, and they are, put these kind of side by side here, they are opposite strategies of one another. So modeling, yes, but instead of using division, we're going to be using multiplication. So as a model, draw 2 and 3/5. What does that look like? That looks like 2 holes. I shouldn't have done a circle here. I'm telling kids don't use circles for fifths because they're a little hard to estimate. All right, so this is 2 holes and 2/5. All right, so what is that if we wanted to only use a fraction with just a numerator and denominator? If I said, how many fifths do I have altogether? Well, the problem is these aren't broken into fifths yet. But I know that my denominator is going to be consistent through all of these, so I'm going to need each one of these holes broken into 5 parts. That's what the denominator tells me. So how many fifths do I have now? Well, this one's 5/5. This is another 5/5. And this is 2/5. If I add all those together, that gives me 12/5. So 2 and 2/5 is equal to 12/5. Another strategy for doing that is if I don't want to skip count 5/5 and 5/5 and another 2/5, students will be able to look at this and say, well, if I have 2 holes and they each have 5 pieces in them, 2 times 5 is 10, but there's 2 pieces in another one that's incomplete. So we're going to add on those 2 more pieces. So 10 plus 2 is 12, and we're working with fifths, 12/5. All right, got one more example to show you. And that is subtraction when we're working with a whole and a mixed number where there is no fraction over here. Common mistake students will do if they want to write these up and down is to subtract and to just, don't you come tell me that ice cream man's here. My son's here to tell me the ice cream man's outside. We got one more minute and then we'll go get ice cream.
He's waiting outside there.
So we're going to take nothing minus 1/3. Do not just bring this 1/3 down, which is the common mistake. Is students will just bring 4 minus 2, bring that down, and bring this down. But remember, this is really 0/3, and you can't do 0 minus 1. So what are we going to do? We're going to regroup just like we did before. I'm going to take a whole, and I'm going to give a whole. This time I'm working with thirds, so I'm going to make this 3/3. So what I'm showing here is I'm starting off with 4 holes. And I'm taking away 2 and 1/3. Well, I can take away the 2 holes, but I can't take away the 1/3 because I don't have this split up yet. So here's where we had to break this up. What we did is we took away 1 hole and we made it into 3/3 instead. So really I have 3 holes and 3/3. 3 holes and 3/3. And then I can take away my 2 holes and I can take away 1/3. So what that leaves me with is 2/3, 1 and 2/3. All right, and with that, the ice cream man is here. Thank you for watching. Go ahead and like and subscribe to my video.